Hello, we are back with research with data, part two. So, organizing and manipulating your data. So, in the previous presentation, we learned how to find data sets, we learned how to download them, we learned about how to conduct research and how to find what you're looking for and go about developing um, um, a, a variety of different visualizations thanks to some handy tools that can be found online. And this time around, we are going to talk about um, how to manipulate data, how to use some online tools to create some visualizations and some additional resources about some additional work that you can do with data. Um, the one thing I had mentioned in the last presentation was that you have to have a question or a hypothesis, something that you're trying to test or look into, an inquiry um, that will help you kind of sort through and figure out what kind of data you want to look at. So in this particular case, for this example, I asked the question of the data set that I showed you in the last presentation from the Analyze Boston website, the 311 service requests, where people from the city of Boston can call 311 for non-emergency uh, requests about everything from potholes to power lights to trash, graffiti, just kind of citywide issues that you come across you may come across on a daily basis in the city of Boston. So if we go back to this data set, the question I asked of it was, and remember the data set was like hundreds of thousands of lines of data of phone calls that individuals have made to this call center at 311 complaining about various things. So we need to really define what we're going to look at within those hundreds of lines. And by doing so, I developed a question, and that question was, where are the most frequent 311 calls for service about rodents made? And how many of them does the city of Boston close or address? In the spreadsheet, there is like the call is made and then there's the closure of that call. So that means that someone at the office that answers the phones for 311, they have sent someone out or closed the case that was opened by the person who phoned it in. So some of them aren't closed, so it's important that we add that extra layer of detail there to make sure that we kind of have a real circumscribed data set. Otherwise, we'll have like way too much. The inquiry would be too broad, and a too broad inquiry would mean too much data and too much to graph. Um, so again, I went back to the website. I downloaded the data in much the same way that um, I showed before, and that you just download it to your computer, and then I opened the spreadsheet up and was confronted with all of these lines, and information, and all of the tab, all of the columns, and there's just so much. So I chose to filter it down in Excel using the filter option, and it helped me. I filtered two columns in this spreadsheet and was able to get the lines down to much less. So I was able to get it down to far fewer lines of information about rodents and about cases that were closed in the city. It was about 1,000 lines, and so I then took that information and uploaded the file in Analyze in trying to try and analyze the information. So I used this website called WTF CSV, and I'm just going to Google for it. And it's by an organization called databasic.io, and they have just some great tools, but this is one of them, and they're super user friendly, which is what I love about it, and great for educators. So I uploaded you can upload the data set, but you can also see a sample data set. So this one's about Titanic passengers. Let's just take a look at the analysis. So you can easily upload a Excel file into this, and it will into this website, and it will transform it to make it look like this, which means it's going to give you information about each of the fields. It's going to give you information about the occurrence of names, the different female or male that were on the boat. In this case, we're looking at Titanic passengers, so the ages of the people on the boat. The most look to be between 24 and 32, and 16 and 24. The tickets that they were able to find, cabins, things like that, fares. There's a lot of information here that we can take a look at thanks to this website. So uploading a file to this is really easy. Just a matter of clicking there and then finding your data, your Excel spreadsheet, and going ahead and uploading it, and then it will transform it into something that you could use in a presentation or a paper. You can even cut and paste graphs right into your presentation. It's really easy to use. I really love it. It's something I just heard about, so it will, as I said, create those visualizations and also interpret the data in a way that is easy to do versus trying to develop a pivot table in Microsoft Excel is tough. I mean, it can be hard, but it's 100% doable. But this awesome website does it for you. So I especially loved that. So that that level of inquiry was what I went ahead and did. I did that piece, and then I took some of the addresses out of so this is that 311 data set. There was some graphs and stuff that came up on here, that the open and closed cases and such. I took a bad screenshot of that page. I apologize. But the other thing I did was I created a new spreadsheet with addresses. So I took this address information because I thought, well, I'd like to see where in the city there are road problems that is relatively nearby Boston University. So I chose some locations, and I put them into this other website called BaxGeo, and BaxGeo will create for you a map based on locations. So if we go to their website real quick, I'm just going to show you that what it does. So many people and organizations are using Excel to store location data in the form of address, zip codes, cities, and states. And will easily create for you a map from your Excel spreadsheet. And so these are the directions for using this website. It's opening a spreadsheet. It's copy and pasting the data. So the lines of spreadsheet, that's what I did. I copy and pasted. I created the lines of data, address, city, state, zip code, and then I copy and pasted that information, and I opened up their web page and I pasted it right into this little box right here. And once I had done that, you you click validate and set options, and then it will develop for you and create for you a link. An additional box will come up, and um, it will email you a link to the visualization of the data, and that link is right here. So we can look at the map that I created based on the Excel. There were only 4 locations, it looks like, in and around Boston University from the data set, from the 311 data set that had some rodent activity that was in fact resolved by the city. So that's good news for us that are in this area. They are responding promptly to issues. So that spreadsheet created this map. So that is how that works. Another visualization tool that I showed in the previous presentation was the Timeline.js by Knight Labs, and it creates timelines for free. The website will build a timeline like the one I made for the United Methodist Women's 150th anniversary. I can show you really quick the spreadsheet that I had to enter data into. Now I compiled this data from books, articles, from archival material that we have here at the New England Conference Archives. So as you can see, the year, month, this is all set up by the people at Knight Lab. So they created this, and you just download or you click over to their example version of this Google spreadsheet doc. And so then you go here and the year is there, the month, the day, the time. So if we scroll down, you can see that one of the first dates is 1869, March 14th. So I put it in again. I put the headline and what I want the headline to look like. I put in all the text I want on that particular part of the slider of the timeline. The media, I had to upload the images to Flickr, or sometimes I grabbed images, in this case, on Google Books, and so that it would populate an image in the timeline. And then I also had to create thumbnails as well for use by the system. These are all metadata points, and so as you can see, and data, this is this data about data. So this is each line here of the spreadsheet that you're seeing is a slider in the timeline, which I will show you now. So the timeline that I created based on this data is on this website. So it's in this exhibition. We made it part of the exhibition, the online exhibition. So now if we click over here, we can go right into, see, that's the Flickr image, but right now you can just slide. You can slide this image over, and there's the timeline on the bottom, and each and every element in the spreadsheet, from the pictures to the text to the dates, are all contained in this spreadsheet. All the elements are there, and this brings it to life in a really cool way. It's a great way to do presentations. So if you don't want to use PowerPoint, you want to try something different, really make it really kind of just be a little bit different than everyone else. I really like this product. It's amazing. So that's another example of ways that we can transform data into the visual sphere. There are other data and software tools and programming languages that will also do this. There's Tableau, Open Tableau, which has become much easier to use. The university has access to a product called NVIDIA, which people seem to like here on campus, but you could go through ISNT for that. The free Tableau, there should be an online public, but this is another way and another website to take a look at to see if it would be useful to you. It's great for analytics. Our circulation staff uses this to count how many people come to the library, how many people use items, things like that. It's a great tool, and it's much, much, much easier to use than it ever has been. So I would, if you're doing a bigger scale project, that kind of software will be best for you, like Tableau or an NVIDIA. The R, the MySQL, and some of the other languages are far more intensive and far more useful to folks that are doing like computer science and engineering work and stuff like that. So, but they all assist with data organization. They assist with manipulation of that data to kind of come to make it work for your project or presentation. And they help with cleaning and also creating a visualization or bar graphs or line graphs or it's usually mostly graphs that come out of this. Excel will also do that, and it's fairly easy to use Excel as well. So I would encourage you to look into additional ways that Excel can be used to create graphs for papers and presentations. There is a more exhaustive list of visualization tools as well at this website. I'm going to plug it right in here and show you. So this is another page that I feel pretty confident is regularly updated. So there's everything from Data Hero to Chart.js to Tableau is talked about, raw graphs. There's some really neat things that are available. Some of them are for, they cost money, so they charge these companies, but others are free. And this Timeline.js is free, and the Batch.geo is free as well, so that's why I really like those. But this is a nice way to kind of get yourself oriented with those simple tools and kind of try things out and see how it goes. I can really quickly, if Excel is on this computer, let's see if Excel is on this computer. I don't know if it is. Yep, it is. I can show you where the visualization tools, oh, maybe not. Nope, I'm just kidding. Nope. Excel is not on this computer. So, but Excel is pretty easy to use too, and it creates the basic bar graphs, line graphs, etc. So I would encourage that. And please, as I said at the end of the last video, please come and see me. My name is Kara, and my email is kjackman, so that's kjackman@bu.edu, and I can help you with your research to look at specifically what you want to kind of look into, and then define what best tools to use to tell that story in your presentation, in your project, or in your paper. Sometimes it's probably more helpful to talk with me one-on-one about these highly specialized tools to define which one is best for you. But I just wanted to give everyone an overview of the things that can be done in the world of data and statistics and visualizing that data. So thanks so much for joining me again, and I'll see you around.